such that the vertices of H is subset of vertices of G, and edges of H is subset of edges of G. Edges of G. So then the graph, any other graph we use, then the graph H having different vertices, that means V or as in E dash, is said to be a subgraph of G. So here we can say that means if we use the vertices of graph G as V and vertices of graph H is V dash, so V dash is always subset of V, and as is we use for H as E dash is also subset of E. So for any subgraph, that means vertices and as is. So vertices of S is subset of vertices of G, and edges of H is subset of edges of G. For example, so we can understand with the example, that means we construct a graph. This is a graph G. This is a graph G having vertices in this form A, B, C, D, E, and F, and A is also directly joined to the vertex D. We write as E1, E2, E3, E4, E5, E6, and E7, having 7 edges. So we write as V the set of 6 vertices A, B, C, D, E, and F. Correspondingly, the set of edges we write as E1, E2, E3, E4, E5, E6, and E7. So for any subgraph, this is the graph G here. So the graph G. So for a subgraph of graph G, we can take any portion of this graph. We can take any portion of this graph. For example, we write as for subgraph. So we can make several subgraphs of this graph. So for a subgraph, we can take any portion. Portion means you consider this portion. So this means having vertices A and vertex F and vertex B. So this portion, we consider only this portion, that means this portion. This is also example of subgraph of graph G. So for subgraph of graph G, because we see that means here we use the as E1, and so also here you use E8 and E9. 9 is that means add also E8 and E9. 9 is added. So V1, E8, and E9. So this V dash we can denote it as A, B, and F, and as is E dash we denote it as E1, E9, and E8. That means E8 and E9. So the vertices of V dash is also subset of vertices of V, and E dash is also subset of E. So here V dash and E dash also subset of V and E. So this is the example of subgraph. So we can make many subgraphs. That means you can consider this portion also be the subgraph of graph G. F, B, C, and E. This is also E9, E2, E5, and E8. Be also example of subgraph. This is also subgraph of graph G. also subgraph of graph G. So you have to remember that the vertices of H is also subset of vertices of G, and edges of H is also subset of edges of G. So such type of graphs is known as the subgraph of graph G. We can take this portion, that means uh, ECD, ECD. This is also subgraph, or you can take this portion and you can consider this. Okay. So vertices of H is G and edges of H is subset of edges of G. H is called the subgraph of G. So here we write H is said to be a subgraph of graph G. Noted? Payal, Manshi, Anshuma, Ankita, Maisha. Okay. All you noted? Okay. So now uh, we write some points. That means H is a subgraph of G. We write as here. If H is a subgraph of G, then all the edges, all the edges of H are in G. All the vertices of H in G, and each edge of H has the same endpoint in H as in G. These are the observations. So if H is any subgraph of G, all the edges of H also edges of G, and all the vertices of H are also G, and each edge of H has the same endpoint of in H as in G. Okay. Now we move next definition. Next definition is spanning subgraph. Spanning subgraph. Spanning subgraph. For spanning subgraph, we define as a graph H a graph H of a graph G we write as subgraph directly. A subgraph H of a graph G is said to be spanning subgraph spanning subgraph of G if H contain all the vertices of G. Contain all the vertices of G. H contain all the vertices of G. So a spanning subgraph need not contain all the edges in G. Need not contain all the edges in G. That means contain all the vertices of graph G. So we can write as all the vertices of H is equal to all the vertices of G. So we write as H is a spanning subgraph. We write two definitions. That means first is for a subgraph. Subgraph, we can take any portion of graph G. But here, for spanning subgraph, that means any graph G contain 4 vertices, also subgraph containing all 4 vertices, but not contain all the edges of graph G. This is the basic difference of graph and spanning subgraph. So we can take an example, so we can understand with the example for spanning subgraph. So we make several subgraphs of any graph by using all the vertices and reducing some edges. Okay, noted. Manshi, Meenakshi, Mukesh. Anshuma, noted. Okay, so we can take an example for graph G. So first we draw a graph G. This is a graph G. So we have only 4 vertices. These 4 vertices, not intersection point as the vertices. So V1, V2, V3 and V4. So this is the graph G. This is a graph G. So how many spanning subgraph can we make? So we make a different spanning subgraphs. That means we consider all the vertices of graph G. We consider all the vertices of graph G. So that means V1, V2, V3 and V4 for making a spanning subgraph. So we can use this as and this as joined to this as and this as. So this is all a spanning subgraph of graph G. Also, this is also a subgraph of G. Every spanning subgraph also a graph because subgraph because we define as every subgraph or any subgraph of graph G is a spanning subgraph. Basic difference is that only spanning subgraph contain all the vertices as graph G. Subgraph be a portion of graph G. So for example of subgraph, we can choose these 2 vertices and 1 edge. This is the example of subgraph. This is example of subgraph, but this is the example of spanning subgraph because it involves all 4 vertices of graph G. all four vertices of graph G. Other, you can spanning subgraph of graph G. You can use this side of graph G, that is this portion. So this is also example of spanning subgraph, and you can use this type of thing. That means this is also spanning subgraph. So these are the example of spanning subgraph. Spanning subgraph. Further, we study spanning tree. So that is a different concept. In definition of tree, tree is a cycle graph. A cycle graph means there is no cycle between them. So this makes a cycle. So a cycle graph. So we study in tree, spanning tree, minimum spanning tree. We find out the minimum spanning tree by Prim's algorithm, Kruskal algorithms. We use the both algorithms to find a minimum spanning tree of any graph. Understand? Tipanshi, Bhavna, Sakshi. Okay. Now we have important points. Note. That means if the number of vertices, that the number of vertices, and edges, and number of edges are m and n, then total number of subgraph, total number of subgraph, total number of subgraphs, which can be made as 2 raised to the power m minus 1 into 2 raised to the power n. You can make 2 raised to the power m minus 1 into 2 raised to the power n subgraph of any graph. And the total number of spanning subgraph, and total number of spanning subgraph, total number of spanning subgraphs, which equal to 2 raised to the power n. Here n represents the number of edges. In spanning subgraph, we involve all the vertices. On the basis of edges, we can construct the spanning subgraph of any graph G. So you have to remember all these points. Noted, Rajni, Shifali. Okay. Now we take some examples. On the basis of example, calculate, that means draw the graph. Consider this figure. Determine the graphs. Graph G minus V1. Second, G minus V3. And the third, G minus V5. G any graph is given, and you minus V1 means you have to remove that vertex. So after removing that vertex, the construction of graph. So that means we can take an example of G. That means the graph G is given in this form. G is given in this form, having five vertices, having five vertices. So this is also vertices. That means vertex V1, vertex V2, vertex V3, vertex V4, and vertex V5. So graph G having five vertices. This shows the graph G. And first, when we solve the first part is shows that of G minus V1. G minus V1. So we remove this vertex. So when we remove this vertex, the construction of the graph looks like as, that means when we remove this vertex, that means we have only four vertices. So we draw this type of graph. That means this vertex also involved here, and this. So we have V2, V3, V4, and V5. So this is the G minus V1 graph. This is G minus V1 graph. So we remove vertex V1. So when we remove vertex V1, so in all the edges also incident with that vertex we remove. So this edge and this edge and this edge, three edges also remove when we remove the vertex V1. Second, G minus V3. So similarly, we proceed this step second for the second graph G minus V3. So when we remove V3 vertex from the graph G, so this graph, that means second part G minus V3. So G minus V3, you can see this graph. So this shows that this is V2, this is V1, this is V5, and this is V2. Sorry, V4. So this is G minus V3, and last third represent the G minus V5. G minus V5. So G minus V5, only a rectangle, or you can say square shape are formed. Square shape are formed. That means vertex V1, vertex V2, vertex V3, and vertex V4. So this is the G minus V5 graph. Okay, so you can draw the graph. That means when removing vertices V1, V3, and V5. Minus V1 means to eliminate that vertex from the graph G. Vibha Thakur, Shivani, Vibha, Shivani. Okay, done. Noted. Manshi, Anshuma, noted. Okay, now we move next. Operation of graph. Operation of graphs. We use operations. So first, union of graphs. Union of graphs. Union, that means addition, add. So we have two graphs, union of graphs. Let we define as let G1 and G2 be two graphs. So the union of two graphs, the union of two graphs G1 and G2 and denoted as G1 union G2 and defined as vertex of G1 union G2. This equal to vertex of G1 union vertex of G2. This is G1 and as of E1 G1 G1 union G2 is equal to as of G1 union as of G2 as of G2. So we consider two subgraphs, that means two graphs. This is the graph G1. This is the graph G1 having vertex in this way A, B, C, D. That means we write as A, B, C, D, and edges are E1, E2, E3, E4. And this is graph G1. Another graph we draw. This is another graph having this vertex as E and this vertex as D and this vertex as A. This vertex as A, and this is E4 and this is E5 and E6. So this is the graph G2. So what is the union of this graph? So you see that if we consider two graphs here, G1 and G2, so the vertices and edges, these were a pair of vertices and this pair of vertices are same. So when we make a union of this graph, so the construction of a subgraph union of both graphs are in this way. That means you construct the complete graph in this way. That means we write as A, B, C, D, and E. So this having E4 and having E5 and E6 and this E3, E2 and E1. So this is the union of two graphs. That means G1 and G2 graphs. So you can write as this is G1 union G2. G1 union G2. So we write as vertex of G1 union G2 is vertex of G1 union vertex of G2. So at least two vertices or one vertices are same in both the graphs. So we can make union of the graph. Similarly, second is intersection of graphs. Intersection of graphs, that means two graphs are given. So we take the common pair of vertices. Pair of vertices or as so any common as. Yeah, noted. Payal, Rajni, Sakshi. Okay. Now we write intersection of graphs. Intersection of graphs, when I take a common pair of vertices or common edge. Intersection of graphs. So the intersection of two graphs intersection of two graphs is possible only if graph have at least if graphs have at least one vertex in common, which may be isolated vertex, one vertex in common. So the intersection of graph G1 and graph G2 will be a graph. This is also a graph such that the vertex of G1 intersection G2 is equal to vertex of G1 intersection vertex of G2, and edges of G1 intersection G2 is equal to edges of G1 intersection edges of G2. So for any graph, that means, for example, we consider two graphs. This is the graph G1. G1 having vertex A, B, C, and D, and corresponding edges E1, E2, E3, and E4, four edges, and another graph G2 having uh, E1, this is uh, B, A, B, C, and E2 and E3. So this is the graph G1. This is the graph G1 and this is the graph G2. So what are the intersection of both graphs? Intersection of both graphs, we see that there is only one pair of vertices are common. One pair of vertices are common. That means here this is AB having as E1 and this is AB having as E1. So the intersection of both graphs we write as AB E1. So this is the G1 intersection G2. G1 intersection G2. So this is the intersection of graph. Okay. So we take the common pair of vertices or as common as. So this is the intersection of two graphs G1 and G2. So when we talk about the edges, so that means as E1 is common, so you write the as E1. And for talking about the vertices, so A and B vertex are common, which is as E1. So this is the intersection of graphs. Noted. Noted. Now, next graph, fusion of graph. Fusion of graph. Fusion, that means we eliminate one vertex from the graph. That means we fuse any vertex, at least one vertex, fuse one vertex from the graph G. So this is known as the fusion of the graph. So we can define as, let G be any graph. Let G be any graph if two vertices, suppose P and Q be two vertices, P and Q of graph G is replaced by another vertex, replaced by another vertex V, replaced by another vertex V. So such that all the edges in G all the edges in graph G incident on P and Q are now incident with new vertex. Incident with new vertex. Then the pair of vertices PQ are said to be fused. Then the pair of vertices P and Q are said to be fused. We take two vertices and that two vertices replaced by the another vertex, only one vertex. So when two vertex replaced by only one vertex, so that vertex is order pair, that means of two vertices P and Q are said to be the fused vertex. So this is known as the fusion of the graph G. Known as the fusion of graph G. For example, G be any graph. G be any graph. The graph is shown in this form. That means this is a graph G. The vertex are we define as P, Q, R, S, and T. P, Q, R, S, T. So the edges of this is defined as E1, E2, E3, E4, and E5, and E6. So this is the graph G. This is the graph G. So in a statement we write as two vertices P and Q of graph G replaced by any other vertex. So here we see that the pair of vertices, that means this pair of vertices P and Q, we replaced by any other vertex. We replaced by any other vertex. So when you replace by any other vertex, so this also, that new vertex also contain the self loop and multiple edges. Obviously, when we remove one vertex from the graph G, so you can see the structure of the graph. That means this is vertex X, we write as it is, that means at same place. But here this vertex Q, this vertex Q we replace by V. V means new vertex, new vertex. So you can say that two vertices P and Q replaced by one vertex. Two vertex P and Q replaced by one vertex. This is denoted as V. And we write as this vertex is T, and this also joined to the T joined to the this vertex, and this also joined to the R. This joined to the R. This is the structure. That means we use this as E1. We use this as E1. So when we use as E1, E1 also joined to the vertex B. This is also joined to the vertex B. This is the vertex V6, and this is vertex E5, and this is E4, and this is E3. So when this as E1 joined to the vertex B, because we fused this vertex, that means two pair of vertices, or we write only one vertex here, V, and we remain this vertex means, sorry, as E2. So E2, so how to draw E2? So E2 draw as a self loop. E2 draw as a self loop. So this is E2 draw as a self loop. So this is the fusion of the graph. This is the fusion of graph G. Fusion of graph G. Fusion means at least we fused one vertex. That means one pair of vertex. We replaced a pair of vertex by one vertex only. That means here we define in graph fusion of graph. That means you have two vertices P and Q. The two vertices P and Q replaced by one vertex. But we join all the edges to that vertex, new vertex, which are already incident in the graph G. So this is known as the fusion of the graph G. Because the degree of the graph are same, we know that the degree of graph G is also equal to degree of fusion graph G. We calculate the degree of graph G on the basis of the number of edges, twice number of edges. Okay. So next lecture, that means we will discuss walk, open walk, closed walk, trail, path, etc. So thank you, students.